Okay, in this example we're going to solve the inequality mod of x plus 4 is greater than mod of a half x minus 2. Solving inequalities involving the modulus function is very much like solving equations. It's just that we have one extra step that we do at the end. So first I'm going to sketch both the left and the right hand sides on the same set of axes. On the left I'm first going to do some optional working out. This extra bit of working out probably won't be needed for you to sketch the graph, but it will help to label which part of the graph is which. So I'm going to write it in piecewise notation. The vertex of this function is at x equals minus 4. That means we have two separate regions. X is bigger than or equal to minus 4, or x is less than minus 4. When x is bigger than minus 4, we end up with x plus 4. And when x is less than minus 4, we end up reversing the signs. So we get minus 4 minus x. So let's sketch the first one of these. Here's a set of axes. We'll first mark a vertex at minus 4 and a y-intercept at 4. Here's our graph. Now, as we already have the piecewise notation here, we can very easily label the two separate sections of this graph. The part of the graph on the right, when x is bigger than or equal to minus 4, has the equation y equals x plus 4. And the part on the left has the equation y equals minus x minus 4. Next we'll plot the second equation. The vertex for this one requires a little bit more thought. To make this modulus bracket equal 0, we need x equals 4. So we have x is bigger than or equal to 4 for one section, and x is less than 4 for the other. When x is bigger than or equal to 4, we get half x minus 2, and when x is less than 4, we reverse the signs to get 2 minus a half x. So on our graph, we can mark a vertex at positive 4 and a y-intercept at 2. Let's draw the graph. And again, we can label the separate sections. The section on the right, when x is bigger than 4, is a half x minus 2. The section on the left is y equals 2 minus a half x. Now you might think that labelling these separate sections on the graph with their equations is unnecessary, but hopefully over the next set of examples I'll be able to convince you that actually it's quite helpful at reducing the amount of mistakes you could potentially make. Next we're going to find out the points of intersection. So first we'll label them. We'll call the one on the left 1 and the one on the right 2. So let's find these points of intersection. For number 1, it's easy to see which two equations we want because we've labelled them. We've got this line, which is y equals minus x minus 4, meeting this line, which is y equals 2 minus a half x. Adding x to both sides gives us a half x on the right hand side, and subtracting 2 gives us minus 6 on the left hand side. Multiplying both sides by 2 gives us x equals minus 12. To find intersection point 2, again we've got the equations labelled on the graph. We've got this line here, which is y equals x plus 4, equals this line here, 2 minus a half x. Adding a half x to both sides gives us 3 over 2x, and subtracting 4 from both sides gives us minus 2. Multiplying both sides by 2/3 gives us x equals minus 4/3. Now that we know the intersection points, we'll consider the inequality. We have the mod of x plus 4 is bigger than the mod of a half x minus 2. So the left hand side should be greater. And in the context of our graph, that means the y values should be larger. So if we consider our first intersection point here, we can see that to the left of the intersection point, in this section, the y values for mod x plus 4 are above the y values for a half x minus 2. So this is part of the region that we want for our solution. And if we go to the right of intersection point 2, we can again see that each value on the red curve is above the value on the blue curve, and so this is also in the region we want. So we'll tick the regions we want, and we don't want the section in between because for that section the blue line is on top. So the inequality we want is x is less than minus 12 or x is bigger than minus 3/4. And that will be fine for our final answer. However, I do think it makes sense to review the different types of notation we could use to write our answer. First of all, we'll look at set notation. For set notation, each separate interval is enclosed in curly brackets and we use x colon in front of our inequality. So we have x colon x is less than minus 12. In place of or, we use the union symbol, and then we have the other region also enclosed in some curly brackets. Finally, we'll write it in interval notation. For interval notation, we say x is an element of, and then if x is less than minus 12, that means it could take any value between minus infinity and negative 12. We use a curved bracket as it can't be equal to 12. And again, we use the union symbol, and then we know it's any value bigger than minus 3/4. So we use a curved bracket for minus 3/4, and then we use infinity for the second part. Okay, here's one for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution then. So, if you got it right, well done, move on to the next example. Otherwise, I'll go through my solution now. So this time we need to solve the inequality mod x minus 3 is greater than or equal to mod of 3x. First of all, we'll write them both using piecewise notation. Now that we have the piecewise notation, we'll draw the graph. The graph of mod x minus 3 has a vertex at 3, and a y-intercept at 3 as well. Let's draw in the line. Let's label up the lines. On the right hand side, we can use our piecewise notation to see that this is y equals x minus 3. And on the right, we have y equals 3 minus x. Next, we'll draw mod 3x. That's got a vertex and a y-intercept at 0. Let's label the parts of the graph. We've got y equals 3x, and we've also got y equals minus 3x. That gives us 2 points of intersection. We'll call them 1 and 2. Next, we'll find the points of intersection. For point 1, we have y equals 3 minus x meeting y equals minus 3x. Adding 3x to both sides gives us 2x on the left hand side, and subtracting 3 from both sides gives us minus 3 on the right hand side. Dividing through by 2 gives us x equals minus 3 over 2. For intersection point 2, we have the line 3 minus x meeting the line 3x. Adding x to both sides gives us 4x on the right hand side, and that leaves us with 3 on the left, which gives us x is 4/3. Now that we have our intersection points, we want to know when is the graph of mod x minus 3, the blue line, bigger than the graph of mod 3x, which is the red line. Well, this time we have a region in between the two intersection points where the blue line is above the red line. That is the region we want. So we can write our answer as x is bigger than or equal to minus 3 over 2, but less than or equal to 4/3. So that's the answer written in inequality notation. Let's also write it in set notation. There's actually 2 ways you could do this. Probably the most straightforward way is just to write it in curly brackets with x colon, and then just put our inequality. Another way of writing it is two sets intersecting. So we could say that x is bigger than minus 3 over 2. And it must also be true, so we're using an intersection symbol, that x is less than 4/3. So here we're saying x is bigger than minus 3 over 2 and x is less than minus 4/3. That's different to if we'd used the union symbol in here, which would indicate two separate regions. Let's finally write it in interval notation. We have x is a member of the following interval. Square bracket indicates that minus 3 over 2 can be included, comma, 4/3, and then another square bracket on the other side because it can be equal to 4/3.